Hello friends, thank you for watching this video. I am Mohamad and today we're going to be discussing caching within our .NET applications. We're going to be seeing how we can actually add much more performance into our application by utilizing caching. And in this video we're going to be discussing in-memory caching, not distributed caching. If you're interested in distributed caching, I have another video which I'm going to be linked in the description down below, where you can actually go and see how we can actually utilize Redis as a distributed cache with our .NET applications. But in this video we're going to be discussing how we can actually utilize in-memory cache and how we can actually set it up, create a caching service, and basically seeing how we can actually put information in the cache, extract it, as well check the expiry time. If you like this video, please like, share and subscribe. It will really help the channel. As well, if you'd like to support me, please consider supporting me on Patreon or buying me a coffee. Now, grab your cup of coffee and let's get started. So before we start, what we're going to be taking a look at is what is caching and how does it fit within our application and our database. We're going to be seeing a flow of an application without caching implementation and with caching implementation. And that way we're going to see the benefit that caching is going to provide. So in this scenario here, what do we have? We have a client, we have an application, in this case that's considered as an API, and we have a database. And if we want to mimic the flow of our application, what's going to happen? The client's going to make a call to our application. The application is going to process this call. And once it's actually processed this call, what's going to happen? The request is going to flow from the application to the database. And then the database is going to provide the answers that we need. And then once it does all of that, the response is going to go back to the application. The application is going to process this response. And once it does that, it's going to send it back to the client. So as we can see here, this flow of our application is pretty straightforward. But in this case, we only have one client. So imagine instead of having one client, we have 10,000 clients trying to communicate simultaneously. So we can see here that the load between the database as well as the application, specifically on this part here, this is gonna get really tough. So we can see here that this area in specific, or this area here, doesn't want to come red. So we can see that this area here, this is gonna be really under a lot of pressure in order for it to get our information. And this could be a bottleneck, because basically what's gonna happen here, every single request from our application is gonna go to the database. It's gonna go through a lot of different networks. It could be if the database server is available on a different server by itself, or a different even region, that's all gonna go, all of this stuff is gonna go from one region to another, get the request and come back here. And we can see here how this can be a bottleneck. So let's see what's the other scenario, what's going to happen if we actually utilize caching. So if we go a bit down here, we can see this is the same application but with caching implementation. And you might think to yourself, okay, what's the difference here? So when it comes to caching, we have different scenarios. So the request is going to be basically the client will make a request. It will go to the application. The application itself is going to process that request, and then it's going to send it to the database. Once it's sent it to the database, what's going to happen? We're going to get back the information which is needed, and then the application server, what's going to happen here is going to actually cache this information. And what do mean by cache is keep a local copy of this data in its environment. And then once it keep a local copy, it's going to save it here in the cache, and then it's going to return it back to the client. So what's the benefit of this? So the idea behind this is, instead of having the information always being stored in a database and relying on the database to be the single source of truth every single time, even though we are basically utilizing this information for multiple clients, what we're doing is we're storing these types of information inside our cache, local cache here, and then basically whenever we need it, we can actually reutilize this information directly from there. And the main part, or basically behind this, is if we go back a bit down, we can see another big implementation, which is here. So in this case, once we have cache implemented, once the client will request the information from the application itself, the application will check if this information exists within the cache. If it does, it's gonna get the information from the cache and return it back to the client. And we can see here, by implementing these types of implementation, we have basically eliminated all of this hassle of being actually relying on the database. Because basically what we have done here is we have added an extra layer where we're actually putting all of the information that we need. And this information that we currently what that we're actually utilizing here is much more closer, because as we said, the database could be living on a different server in a different region, while the cache in this instance is a local memory cache. It's basically available whatever the server is. So basically it's going to be very close to the server. It's going to basically be able to put this caching information from the server memory itself and then send it back to the client. And we can see like we are basically eliminated full set of dependency just because we have cached this data. And this data here, it could be, for example, we can set a limit on it. So what does a limit mean? So for example, let's say I want to cache a data, but I only want to be validated for only 5 minutes. So this means that this data is only going to be valid for 5 minutes. So every 5 minutes, I'm going to get a fresh copy of my data and cache it again. So that way, basically, I make sure that I always have the latest version of my data available for my cache. I can basically make sure that no matter what's the changes that's going to happen, I'm always going to update it. I can even introduce certain set of rules and regulations. So for example, if someone updates the data, I can directly invalidate the cache and have a new version. So there's a lot of different potentials which we can actually implement when it comes to actually cache management. But in this scenario, we're going to take it the easiest way, and basically we're gonna just make sure that after a certain amount of time it's gonna expire. So that's one item. And another item that we also need to discuss is the different types of cache. So in general, there is gonna be two types. There is the in-memory one, which we're gonna be exploring in this video, and there's gonna be third-party ones like the Redis. And Redis, I have already created a video about it. So if you wanna watch that, I'll link it here somewhere where you can actually watch it. But as for the in-memory database, or in-memory cache, excuse me, the in-memory one is basically gonna be directly stored in the application memory. So the same memory that the application is utilizing, like the RAM of the application itself, there's gonna be a caching there functionality that the application can utilize. And that's the big difference. The big difference between an in-memory cache as well as the third-party cache is basically third-party, all of the caching is being handled by a third-party service. On the other hand, the in-memory one, it relies heavily on the memory of our application, the RAM, which is the application is running in, and that way it also limits the amount of information we can set inside the memory of our application or inside the cache in order to make it as much performant as possible. So in this video, we're going to be exploring in-memory one. If you want to learn more about the Redis implementation, I'll link that video here so you can also watch it. But before we jump into that, we're just going to do a bit more explanation about the difference between an in-memory and third-party. So the main difference here is, as we said, so here we can see the main differences between actually having a distributed cache and in-memory cache. So as we said, an in-memory cache is basically we are reliant on the actual memory of the application, the RAM that actually utilizes. So let's say we have a server, and this server basically have 5 GB of RAM. Basically what we can do is we can, for example, allocate 1 GB for caching, and it's gonna be 4 GB for the application. We cannot allocate it, it's all gonna be automatic, but for the sake of this example. So we can see here that every single instance of our application is going to have a different on cache. So for example, let's say my application has scaled from 1 server to 2 servers. We're going to have two different sets of in-memory cache, and basically these two different sets of in-memory cache, they're going to belong to these two different servers. So for example, we can see here that this server itself will have 1 GB of cache memory and 1 for the application. Another server here will have different 1 GB for cache memory and the other one for the application itself. So what happens here if a request comes to let's say I'm a user, I'm interacting with the application, and I can't really decide as a user to which server my application will go. That decision is gonna be made by the load balancer, because basically it will see which server has less traffic and it will route my request to it. So here, for example, if my first request come to this server here, let's put this server as 1. If my first request come to server 1, and let's make it this in different colors, so let's make it in nice green. So if my first request come to server 1, and basically I get my information that I needed, and then basically what happens, the server will cache it inside the caching memory and then it sends it back. Perfect, that's the expected scenario. But what happens if I do another request and the load balancer says, okay, server 1 is fully is not accepting any more requests because it's full with it's full of capacity, but server 2 is actually taking requests. So what happened here? The request is gonna go to server 2. It's gonna check the cache. It says, okay, it does not exist in the cache. So what is gonna happen? It's gonna connect to the database, get the information again, then store it in the cache, and then send it back. So we can see here that these caches between server 1 and server 2 are not gonna be synchronized, and this can cause problems on a large scale, because basically we are heavily relying on this caching of this server itself. So what happens if this instance crash? So all of the cache that inside this instance is gonna basically disappear, and basically all of those requests to the database, they're gonna happen again. But on the other hand, if we're having such a distributed memory, what happens? This distributed memory is going to be responsible for storing the cache. So we're not actually storing the cache inside the server itself of where the application is running. We are delegating this to a third-party service like Redis. And this server, we can, for example, put it in the same region where our application is running, so we make sure there is no latency when we're trying to get this information, so on and so forth. But the main point behind this is going to be an extra instance that we need to manage in order for us to make sure that our application is actually executing as it should, and basically our application have the right resources to the cache no matter what request is coming from which server, because basically the cache is not linked to direct servers, it's being handled by third party. So we can see here that this one, although it's a much better approach, it has much more complexity when it comes to setting up an instance of caching. The first one is much more advised for a very small application where you basically don't need to have a full set of a caching server, where you only have a minimal set of data that you want to cache. Again, it all depends on the scenario, but if for a large scale application, having a distributed cache is a much more better approach than relying on an in-memory one, because this is gonna basically cause a lot of problems, specifically when it comes to scaling. On the other hand, it's much more cheaper, it's much more direct, specifically for small to a bit medium application. On the other hand, distributed cache is much more for large enterprise application, when you have a lot of sets of data that you need to make sure that you need to keep in the memory, as well as make sure that it's available to any instance of your application, even if that instance is not functioning, and specifically if you're trying to do a lot of scaling up, so you don't really when you're scaling up, that information will be directly available to these new instances without actually having to rely on its own memory to cache this data. So that's the main difference between in-memory and distributed cache. And as I mentioned inside this video, we're going to be basically exploring in-memory and how we can implement this. And before we jump in coding itself, we just want to explore one last item, which is the logic behind what we're going to be doing. And this logic is going to be basically pretty straightforward. So let's just try to see how it works. So here, let me just make this a bit smaller. So this is going to be the logic that we're going to be following. So the request will come to our server. We're going to basically check the cache if it exists or not. If it does not exist, we're going to get the data from the database. Once it's got the data from the database, we're going to be setting it to the cache and then return it back to the user. So that's going to be the main flow that we're going to be following. In case the information exists in the cache, we're going to check its expiry date. If it is expired, we're going to get the fresh new version of the database and then set the cache and return the data. If it's not expired, we're going to just return the cache as is. And this is the flow that we're going to be implementing today. So I hope this intro, I was able to give you a quick introduction about caching, the mechanism, and why do we need caching. And if you have questions, please put them in the comments down below. Now with that said, let's start into the fun stuff and let's start actually writing our code. So the first thing that we need to do is we need to actually make sure that Postgres is installed and configured correctly. Once we do that, all we need to do is then create our web application and start basically taking it from there. So let's get started. So in order for us to make sure that Postgres is installed, I have utilized Homebrew here in order for me to install Postgres on my machine. So I can just utilize Homebrew, actually brew services list. And basically here it will allow me to see all of my services which is running utilizing Homebrew. And as we can see here that I have Postgres 14 running successfully and says it started. So if you want to install Postgres utilizing Homebrew, all you need to do is just put brew install Postgres. And basically this will install Postgres for you. I have already installed it and it's running, so I'm not gonna install it again. And once you make sure that it's all successfully installed and running as it should be, the next step for us is we need to connect to our Postgres instance. And once we connect to our Postgres instance, we're gonna create a user, and then we're gonna be basically able to create a database, grant that user permission to the database, and then we can jump into our web application. So first things first, to connect to our Postgres instance, all we need to do is put PSQL Postgres, and this basically allows us to connect with the Postgres terminal. And as we can see here, our terminal changed from running in our normal folder directory into our Postgres. And then all I'm going to be doing here is just create role. I'm going to call it Mohamad API. I can call it whatever I want with login password. And I'm gonna 1, 2, 3, 4, 5, 6, 7, 8. And here you can see I have created a role successfully. Then I'm gonna basically alter my role to give me more permission. So I'm gonna make myself a super user. I'm gonna put alter role Mohamad API with super user. And now here I have basically gave myself full privilege access to my Postgres. And now all I'm going to be doing is creating a database. I'm going to say create database. I'm going to call it sample API DB1. I have created myself a database, and basically right now what I need to do is I need to grant this user access to this database, so they will be able to update it, do any changes that we need, create tables, so on and so forth. Again, it's going to be pretty straightforward. So we're going to just grant connect first on database. And I'm going to give this database name, which is going to be sample API DB1. I'm going to say to who I want to grant this. It's going to be to Mohamad API. And once I've done all of that, basically I have set up. So what we did here is first I have installed Postgres. If you didn't install it already, you should be able to install it. Then I'll connect it to my Postgres instance. I created a user. I gave it a password, and then once I did all of that, I was able to basically grant admin privilege for that user, so they will be able to connect to my Postgres server and basically do whatever they need from there. It's not always the case that you need to give your user admin access, but in order for us to make this video as simple as possible, we just granted admin. So once we did all of that, the next step that we did is basically we created a database, and then we granted that user the ability to log into that database and actually utilize it. And because they have already admin access, they will be able to create, delete, and basically manage the tables inside the database as they need. So now that we have done that, the next step for us is to create our web API. So let me quit from this. I think it's sorry, it's other one. Okay, so now that I have exited from this, the next version is I need to basically check the version of my .NET SDK, and all I need to do is put .NET -- version. And as you can see here, I'm running on the latest version by the time of this recording, which is going to be 7.0.200, which is great. If you have any recent version of .NET Core, that should be more than enough. So once we have done that, the next step is to create our web API. I'm just actually, before we do that, we need to utilize EF Core tools. So if you don't have it installed, please install it. And I'm going to show you right now what is the command that you need to do in order for you to be able to install that EF Core tool. And it's going to be pretty straightforward. All you need to do is just put .NET tool install -- global, because you want it to be available everywhere on your machine. And we're going to put .NET -ef. It's going to tell me that's already installed on my machine, but make sure you install it if you don't have it already installed. So once you do all of that, now we need to create our web API, and for that we're going to be utilizing the .NET new keyword. And basically I'm going to put web API. I'm going to give it a name. I'm going to call it web API caching app, anything that I want. Now this will take a couple of seconds. Now we can see it's actually completed. I'm going to navigate to API caching app, and I'm going to open it in Visual Studio Code. Okay, let's see how this is looking in Visual Studio Code. Okay, perfect. So what I'm gonna be doing right now, the first thing is I'm gonna open my terminal and just basically build my application to make sure that everything is running as it should be. So now inside my terminal, I'm just gonna put .NET build, and here I should be able to see that my build application is built successfully, and as we can see here, I got the green tick, which means that it has already completed. So the first thing that I need to do is I need to install a couple of packages, and those packages, first of all, they're gonna allow me to actually connect to my database in order for me to basically store information there, and basically allow me to utilize Entity Framework core with Postgres. So that's the first thing. And the second, I need to install a package which can allow me to utilize the caching services that .NET provide in order for me to utilize the in-memory caching. And these packages are really important for us to utilize, because without them, we're not going to be able to utilize any of those services. So the first package that I need is going to be the Entity Framework one. So I'm going to put .NET. Let's see how this is looking. Okay, package. I'm going to put Microsoft .entity framework. Okay, it's not really clear, but I'll make it visible now. Core. Okay, I'm gonna make this a bit higher so you'll be able to see it, and I'm just gonna show you the command that I added, which is this one, .NET add packages, Microsoft.entity framework core, and we can see it's completed successfully. Let me clear this up. So the second package that I need to install is also going to be related to Postgres. So we're going to put .NET, okay, add package and PostgreSQL.entity framework core.postgres. Perfect. Now the third package is also going to be related to Entity Framework. So I'm again clear this. It's going to be .NET add package Microsoft.entity framework core.design. Perfect. Let's clear this again. And I'm going to use the last thing. Instead of design, I'm just going to put tools. It's going to be the same thing. And the last NuGet package is going to be related to caching. So again, .NET add package system.runtime.caching. Perfect. All I'm going to do right now is clear this up and then do a .NET build. And this will allow me to see if everything is running as it should be. Okay, great. And now if I come here and click on the CS Proj, and if I scroll a bit down, let's make this a bit smaller. And as we can see here that I have all of the packages that I want, which is going to be 1, 2, 3, 4, 5, exactly the one that I want available for me to utilize. Great. So now that my packages are installed and basically they are configured correctly, the next step that I need to do is I need to first create a model. And basically this model is going to allow me to create a table inside my database. And because the F1 season is around the corner, we're going to be creating an F1 application. And basically from there, what we're going to be doing is that I'm going to be creating an API DB context, which is going to allow me to actually communicate my changes or basically my tables into my database. And then I'm going to utilize the migration in order for me to create those tables and manage those tables. Once I do that, I'm going to be basically then able to add my caching services. So let's see how we can actually implement this. So first things first is inside my root directory, I'm going to create a new folder and I'm going to call this folder models. And inside this models folder, I'm going to create a new class. I'm going to call it driver.cs. And the first thing I'm going to provide the namespace, and it's going to be API caching app.models, and then here I'm gonna put public class driver, and it's gonna be a pretty simple class. All I'm gonna put is the integer is gonna be an ID, and then all I'm gonna put another one is gonna be string, it's gonna be the name of the driver, And then I'm gonna put another one, gonna be int, which is gonna be driver number, racing number, I'm gonna put racing number. And lastly, I'm just gonna put the team. Okay, so once we have done all of that, again, .NET build is our friend, just to make sure that nothing is broken, and we can see it's building successfully. The next step after we did all of that, I'm gonna create another folder inside my root directory. And this one, I'm gonna call it data. And inside my data, I'm gonna create a new class, and I'm gonna call it API DB context. Again, the namespace is gonna be the first thing. Data, actually, it's gonna be API caching.data. Then it's gonna be public class API DB context. We're gonna inherit from the DB context class. And let's fix those references. Okay, perfect. And now I need to provide my constructor. Oops. Okay. And here inside my constructor is gonna be pretty straightforward. I need to pass the parameters that I need. We already done this a lot of time, but let's just do it again. All I'm gonna put is DB context options. And then I'm gonna pass my API DB context. I'm gonna call this options, and I'm just gonna pass this back to the base class. Okay, great. So now I have done this. All I need to do right now is just I need to add a reference to my models table, or basically to my drivers table. So let's do this right now. Do it here. So all I need to do is put public dbset, and it's gonna be the driver table. I'm gonna call this drivers. Again, I'm gonna put the public get and set. And let's fix those references. Okay, perfect. So once I have done all of that, again, let's fix this. Perfect. Now if we do .NET build, let's see. Okay, great. So now what did I do? I first created my model, and this model basically will allow me to create my table inside my database. Then once I have done that, basically I created my API DB context. It allowed me to pass the configuration and actually add my model into my DB context. And the next step is right now I need to actually create my connection string inside my app settings, and then I'm gonna actually inject my connection string into my program.cs, so my application will be able to know that there's a Postgres database there, and it allow me to inject it as a service inside my controllers. So that's gonna be the next step for us right now. So inside my app settings.json, all I'm gonna be doing here is add my new connection string, and I'm gonna put here, I'm gonna put here connection strings, and I'm gonna call this the default sample. Let's call it sample DB connection, or default connection. We can call it whatever we want. And I'm basically gonna pass the connection string. I have already prepared this, so just copy paste this. Okay, yes, copy paste this again. And here basically I'm connecting to my server, passing in a user that I created previously, and my database. I'm just gonna call this sample DB, I think it was API DB1. Okay. And now once I have done all of that, the next step for me is I'm gonna go into my program.cs, and I'm gonna be basically loading my connection string here. And then once I load it, I'll be able to actually inject it into my services. So that's gonna be pretty straightforward. So all we need to do here is can put var connection string equal builder dot configuration dot get connection string, and I'm gonna pass the name of my connection string, and in this case it's gonna be sample db connection. Pretty straightforward. And now once I have it, I can inject it directly into my services, and for this I'm gonna put builder dot services dot add entity framework and PSQL. And then here all I'm gonna be doing is actually configuring it. So I'm gonna put dot add db context, and what's the db context that I have is called API db context. It's gonna tell me that it doesn't recognize it, so I need to fix these references. Okay, great. And now I need to pass the options, so I'm just gonna put options, and let's put it here, and here I'm just gonna put options dot use npg. Oh, I need to add this reference again. Use npg sql. Let's see if I can fix this reference. Yep. And now here all I need to do is just pass my connection string, and that's it. So it's a pretty straightforward implementation. So all we did here is basically I first get my connection string utilizing the builder.configuration.get connection string, and then basically what I did here is I just connected to the entity framework services. I added my DB contacts that I have, and then basically utilizing their options, I was able to pass the connection string, and basically this will go directly into my API DB contacts when it's being initiated as a constructor, and it will be passed to the base class, and basically from there I will be able to utilize it. So once all of that is done, again, our best command is .NET build to make sure everything is building, no build errors. Great. And right now what I have is pretty straightforward. I have my API already set to utilize a database. I have my API DB context ready, my program.cs and my startup information is all there. So whenever my application is actually starting up, it will be able to actually know that there's a database there, and it needs to be able to connect to it, and it has all of the right information through the connection string. So right now, although I have all of this set, my database does not contain the latest changes, or does not even contain my tables. So in order for me to actually update this database to contain my tables that I have created inside my application, all I need to do is, first of all, I need to create a migration script, and that will basically convert all of my CS, basically C# code into SQL code, so the Postgres will be able to actually take it and create it. And then I need to do an database update command, which will basically take that converted text from the Postgres, from C# to Postgres, and actually implement it against my database. So these are two crucial commands that we need to implement. The first one is basically creating the migration script, and the second one is to actually implement that migration script. So in order for us to do that, it's pretty straightforward to create a migration script. So .NET EF, and that's the EF tool that we have created, that we have installed previously. And here, this EF command here is referring to that tool that we have installed. And I'm gonna put is migrations add, and it's gonna ask me what the name for my migration. I'm just gonna put, it's gonna be initial migration. And right now, we should see is actually building. And on the left hand side, we can see that there's a new folder which has been created, and this folder here is called migrations. And if we click on it, we can see that we have a new tables which has been created called driver. We can see that the property ID, and we can see that it's basically contain all of our table structure, so ID, name, racing number, and team. And we can see here that it automatically gave the ID as a primary key, which is exactly what we want. So now that we have created the migration script, the next step is for us to actually implement it in our database. And to do that, we're going to put .NET EF database update. And before we run this command, let's explain what this command does. And basically, in simple terms, what this command will do is gonna go to the migrations folder. It's gonna scan all of the migration, check whatever migration exists there, and then it's gonna go to the database. It's gonna create a migration folder inside my database, migration table inside my database, and then it's gonna match. Do I have the latest version of the migrations? If it does have the latest version, so there is nothing to be done. If there is a missing version of the migration, what's going to be doing, it's going to implement that migration. If it is implemented successfully, it's going to add that migration version into that table, so it will keep track of all of the migration. So it's a pretty smart system. So right now all I'm going to be doing is just click on enter, and here we can see that's actually building and it's done. So let us double check how this is working. So let's open DB Beaver. And basically, so I'm sorry I cannot make this a bit bigger. I'm not sure how to do it, but it's going to be pretty straightforward. I'm going to choose Postgres. I'm going to add my information here and the database. Let's copy paste the name from the connection string. And the username is going to be Mohamad 1234567 That's going to be my password. That's connection. It's connection successful. Click on finish. And now if I come here, if I open this up inside my database, inside my tables, you'll be able to see right now that I have my drivers table there, and I will be able to see also that you have my migration history. Let me just create a screenshot and I'll be able to zoom in on this. Yep, and as you can see here that I have my table created, sample API DB1. I have here that my two tables, my drivers table that has just been created, and my entity framework migration history, which has also been created for me, which is great. So now that I have made sure that everything is running as it should be and it's created, the next step that I need to do right now is to actually start implementing my caching logic. And basically the reason that I want to implement my caching logic before I create my controller is basically all I want to do right now is just create the interface for it, create the actual implementation for that interface, and then inject it into my program.cs, so that caching service will be available whenever I needed to utilize it inside my controllers, any other area that is needed. So that's going to be the next focus. First creating the interface for that caching service, and then actually creating the implementation for it. So inside my root directory again, I'm going to be creating a new folder, and this folder is going to be called services. And inside the services, I'm going to be creating a new interface, and for this I'm going to be calling it cache service.cs, and this is going to be the interface where it's going to contain all of the logic for my caching, all of the method for my caching service. Again, we're going to start by the namespace API caching app dot services. Then I'm going to put public interface, and I'm going to call this iCache service, and I'm going to make it as generic as possible. So I'm going to make it of type T, and I'm going to pass here the string key, and then I'm going to put bool set data of type T again, and we're going to pass string key, then I'm going to T in the value, and then date time offset, and it's going to be the expiration time, and lastly it's going to be the delete. Okay, so a pretty straightforward interface that I have here. So the first one is going to be get data, and I made it as generic as possible, so I'm utilizing T here in order for me to make it as an anonymous type, and basically whatever type of T I pass, it's going to be returning, and it's going to take the key of the object that I need to get from my caching service. Set data as well of type T here. We can see that this is going to be the key that is going to be matched upon. This is the value that we're going to be able to set that key for, and then we're going to specify the expiration time, how long will this last in our cache, and lastly we're going to be removing the data from our cache basically based on that key. Pretty straightforward. And the next service here, all I'm going to be doing is I'm going to create another class right now, and this is going to be called cache service.cs. And basically this is going to be the implementation of my interface. So the first thing that I need to implement is my namespace. Again, it's going to be API caching dot services. Then it's going to be public class cache service, and it's going to inherit the I cache service. And it's going to implement the I cache service, and we can see it's not happy because I did not implement the method. So let's implement it right now, and we can see, let me close this. It automatically generated for me the 3 methods that I need to implement: the get data, remove data, and set data. So let us now fill these implementation, and we're gonna start by the get data. So I'm gonna remove this, and let's put a try catch, and we're gonna put exception ex. And all I'm gonna do here right now, throw. So there is a lot of different ways where we can actually implement actual getting of the data. Again, this is a very simplistic version of how you can implement a caching service. So that's why all I'm doing right now is just throwing. I'm not adding into the log. I'm not actually doing anything with that error. I'm just throwing that error back up. So again, this is a very simplistic way to implement the caching. So again, here all I'm gonna be doing right now is just getting my information that I needed. So I'm gonna put, because it's gonna be of type T, and here I'm gonna specify the item that I wanna get. It's gonna be equal, and then I have to cast whatever I get back into that type of item. And all I'm gonna be doing is I'm gonna utilize my memory cache. I did not specify this, I'm gonna specify it now. .get, I'm gonna pass the key. So I forgot to set up my memory cache, which just do it right here. And here was gonna allow me to put private object cache I'm gonna call it memory cache equal memory cache dot default. Okay, let's fix those references. So here is gonna utilize the caching service. And basically what I'm doing here, so this line here, this is really important. This will allow me to connect to my in-memory cache or in-memory caching services that ASP.NET provide. And basically this in-memory cache will allow me to actually get access to the cache inside my application while it's running. So something to note here is an in-memory cache is whenever the application shuts down, the cache is completely wiped out. It does not last. Other than third-party cache like Redis, for example, if the application stops, everything in the cache will still be there. And whenever the application starts up again, as long as it did not expire, it will still be available for it. On the other hand, the in-memory cache, as long as the application is running, the information inside the cache is available. But once that application stops, the information inside the cache is basically gone. So that's something to keep in mind here. And this sentence here basically is going to be the object cache. It's going to allow us to tap into the caching of that of our application while it's running in order for us to set information there. So I just wanted to clear that point out. So now basically all I need to do back into my get data is just return item, because what I did here is basically specify the item type as of type T, whatever I specified here. And here basically what I did is I cast it, because when I got it back, as you can see, it returns it as an object. And I don't want to return it as an object, I want to return it as the actual type. So I'm casting it back to the type, the original type, and then I'm returning it. So that's going to be the first part. The second part that we're going to be doing is, before we do the remove data, let's do the set data, which is also exciting. So again, it's going to return here boolean. So I'm going to put bool result equal true. So that's going to be the default default return result if it's true or not. So now let's do another try catch. Again, it's going to be an exception ex, and if anything happens, I'm just going to throw that exception. Okay, and The next step for me here is I'm gonna basically try to actually get, so I'm gonna put if. I wanna make sure that this key is not null because I don't wanna send the request to my cache if the key is null. So I'm gonna put if, basically not string dot is null or empty, and here it's gonna be for the key. So if it's not like that, I'm able to get my information, set my information. So I'm gonna put memory cache dot set. It's gonna ask me for my key, so I'm gonna put the key, and then here I'm gonna put the value, and I'm gonna put the expiration date, expiration time. So that's gonna be the main thing. So what I did here is basically I checked if this key is empty or not, and based on that I was able to set it. So if it is empty, I'm just gonna return. I'm gonna put res equal to false because basically I was not able to. It's empty, so it will not return success. And all I'm gonna be doing here right now is just return res. So it's a pretty straightforward implementation. So I just created a variable because that's what I'm gonna be returning. Created a try catch, and basically inside here what I did is I checked if that key is gonna be null or not. If it is null, I'm just made sure the response is gonna be false in order for it to be returned. If it's not null, I was able to set it inside my cache, and then I returned true. And the last implementation that we need to do right now is just gonna be the removing of the data, and again it's pretty straightforward. So again we're gonna do the same implementation, res equal true, again try catch, again exception ex, throw in case anything goes wrong. And what I'm gonna be doing here is also I'm gonna take some of this logic and then just update it instead of me retyping everything. And all I'm gonna be doing here is something like this. So in case the key is not empty, let's fix the spacing. So in case this key is not empty, I'm just gonna put var result equal underscore memory cache dot remove. I'm gonna pass the key, and that's it. As simple as that. And here what we can do here is yeah, let's keep it like this. No need for something else. So let me open my terminal and let's do dotnet build. Okay, great. Now we can see that my application is building. I have a lot of warnings, and that's because basically I did not implement the proper exception handling, and I did not and the keyword value here we can see this is a possible null scenario, so I need to also add if it's not null. That's an extra feature that I can implement, which basically I check if my object is coming is null or not, so I don't store empty items inside my cache. But again, just for simplicity's sake, I just check the key value. You can actually add this logic there if just to make sure that your object is not gonna be null. So once we did that, the next step is I'm gonna go to my program.cs, and I'm gonna be able to inject all of this inside basically my services inside my application. And in order for me to do that, I'm gonna go to builder.services, and here I'm just gonna say add scoped, and this will allow me to inject my service into the scope of every request. And I'm gonna pass the iCache service, and it's gonna be cache service, and all we need to do is fix those references now. Okay, perfect. So now that this is done, again, my favorite command is going to be .NET build, just to make sure everything is building as it should be. Perfect. Let's close this, this, and this, and this, and let's close all of them basically. So now what I'm going to be doing is inside my controllers folder, and here we're going to be doing the last step is basically creating a controller where we have some CRUD operations going to allow us to get and set, and we're not going to go implement the full CRUD. We're just going to implement the get and the set functionalities. And basically create and get the information. So we can see how we can actually add information to our database and to our cache. And basically once we get them, we're going to see how we can actually first get the information from the database and then actually cache those data. And basically because they are cached, whenever we need it, if it's within the time frame of the expiry, so it did not expire yet, we can actually get it directly from the cache. In case it expired, we'll go back to the database and get the latest version. And this is basically will mimic the real world scenario where you have basically a database and you have a lot of information there, but you don't really want to go every time to your database to extract the information, because that's going to be, first of all, it's going to be really consuming on the database. It's going to take a lot more time than actually getting it from the cache, and basically it's going to require a lot of processing power from the application to be able to connect to the database, extract this data, process them, and return it. On the other hand, if it's in the cache, it's much more faster and simpler just to extract this data out of it. So that's what we're going to be doing next. So inside my controllers folder, I'm going to basically create a new class, and it's going to be pretty straightforward. It's going to call drivers controller .cs. And here all I'm going to be doing is first of all put the namespace, which is going to be API caching .controllers, and then I'm going to specify my attribute is going to be an API controller, and then I'm going to put the root, it's going to be controller, and then it's going to be pretty straightforward. The C should be not capital. It's going to be public class drivers controller. It's going to inherit from the controller base. And now let's fix this references. Okay, perfect. And now all I'm going to be doing is, first of all, I need to connect to my API DB contacts and my cache. So I need to initialize them through my constructor. So first of all, I'm going to put private read only, and then it's going to be the cache. So iCache service, I'm going to call it _ cache service. And the other one is going to be my API DB context. I'm going to call it DB context. Let's fix those references. And now let's close this again. We don't need it. And let's fix this. And now all I'm going to be doing is creating my constructor and initialize them through the constructor. And because I have injected them inside my service, inside my program.cs, the dependency injection will allow me to actually initialize them through my constructor. If you don't know what dependency injection is, I have a video which go through it in much more detail. I'm going to be linking it here somewhere where you can actually go watch it. But just so you understand how are we able to access this through the constructor, is because of dependency injection and because we have injected in those services into our program.cs. So whenever the application is starting up, it will basically make this application, these services available for us inside our application, inside our DI container, dependency injection container. So right now let's copy this, and this is going to be cache service, and let me copy this, and I'm just going to put it here. And here all I'm going to be doing is I'm going to put the cache service equal cache service, and DB context equal DB context. And now that I have basically initialized my service, I can actually create my endpoints. So the first one is going to be the HTTP GET, and I'm just going to call this drivers, and it's going to be pretty straightforward: public async iAction result. I'm going to call it drivers get. And here basically it's gonna this is gonna be a get function where I get all of the drivers. So I'm gonna put first check if there is any information inside my cache. So I'm gonna put var cache drivers equal _ cache service dot get data. And here what I want is I want an enumerable of drivers. So that's what I want to get out of it. And this is gonna be the key that it should look for inside my cache. And again, just to re-emphasize, inside my cache, the way I store information is through key value pair. So the key here that I specify and the value is the data. So the way that I actually look for item inside my cache is by looking for the keys. And here I'm looking for the key, which is gonna called be drivers, and it's basically allowing me to get the list of drivers that I need. So once I do that, I need to check if this information is valid. So I'm gonna say if cache drivers, first of all, is not null. And cache drivers dot any. Actually, let's make a dot count is bigger than 0. So all I can do right now here is just return okay with the cache driver, because basically that's all I need. Because if it's not null and the drivers count is more than enough, basically that means that I'm able to get them. Else what I need to do is I need to get them from my database. So what I need to do is to that I'm gonna put cache driver, yeah, let's call them drivers, var drivers equal let's say db context underscore db context, let's make them as an await dot drivers dot to list. Just gonna make them as simple as possible to list async. Just get everything. We can add more logic here, but for now, for simplicity's sake, we're just utilizing as is. And then I'm gonna, basically what I need to do is I need to get whatever information that I got right now, I wanna save them to my cache. So first of all, I need to specify how much time they're gonna be living inside my cache. And then once I specify the amount of time, I can save it. So I'm just gonna create a new variable called expiry time. It's gonna be equal to date time offset dot now dot add minutes. So I can make it in minutes, milliseconds. I'm just gonna make it 2 minutes. Yeah, that's more than enough. And then here I'm gonna be utilizing basically my cache service to set the data, and it's gonna tell me what type of data you wanna set. I wanna set an enumerable of drivers, because it needs to match whatever we're getting, so both of them are going to be list. And then here I need to specify the key, which is going to be drivers, and then the values is going to be drivers, which we got from the database. And then I need to specify the expiry time. And then once I did all of that, all I need to do is just return back my drivers right now. Okay, so basically this is going to be the get. Where I can see here, actually this needs to be a task because it's an async. Okay, so here what I'm doing, let's do a quick recap of what I have done here. So the first step that I did is I checked my cache to see if this list of drivers exists under the key name drivers. Then what I did is I checked if this is empty or null. So if it's not empty or null, I return it directly from the cache. If it is null, if there's nothing there, all I can do is I connect to my database, get the list of drivers, and then save them in the cache, and then I return the value. And now the last one is going to be doing is I'm just gonna create my post, and basically it's allow me to create the drivers, and we can test this out. Can be HTTP post public async task action result. I'm gonna make it post, and here I'm just gonna put the driver. I'm gonna call driver whatever I want, and here I'm gonna put var object because if I update it, okay, that's no need for this. So all I'm gonna be doing is I'm just gonna put await underscore db context dot driver dot add async driver, and then I'm gonna put await underscore db context dot save changes async, and then lastly I'm gonna return okay and driver dot that's it driver. just gonna return it as is. And that's pretty straightforward. So now let's run it and see what happens. So I'll go to terminal and just type .NET run. And it's running. Let me take the port number here and let's go back to my web browser. What is this? My web browser. Okay, let's see how it's looking. Okay, I'm gonna pass here. I'm gonna put swagger / index.html, and I'm just gonna zoom in. And all I'm gonna be doing first is post a new driver. So again, the ID1 is gonna be named Lewis, and racing number is gonna be 44, and the team is gonna be Mercedes F1. And I can click on execute, and we can see we got a 200. Let's add another driver. Let's put George. Racing number 63, again with the same team. And now what I want to do right now is I want to check the get. So try it out, execute, and we can see we're able to get this, and we're able to get it again. So it's working, we're able to get this. So and as we can see here that it's the first time it was able to connect to my database and get my information. But in order for us to actually investigate it further, we need to run it in debug mode to make sure that it's working as it should be. So let's open it in Rider. Okay, so all I'm gonna do is just debug. And inside my controllers here, I'm just gonna put the breaking point. Okay, it's gonna create an issue because I think it's still running here. No, okay. So now let's go back to my web browser here and just click on execute again. So the first time, it's not gonna come to this because it's empty, it does not contain anything. We can see it's null. So it's going to the database, getting the drivers, setting the expiry, and we can see here there's 2 drivers now. And if we go back, we can able to see the results. And now if I execute this again, we should be able to see right now that the cache driver is not empty anymore. We have 2 drivers. So because it passed this condition, it's gonna go directly there. It will not even bother going to the database, and basically we'll be able to get our results directly from there. So let's do a quick summary of what we have done so far. So what we have done here right now is we have implemented a logic where basically our application will be able to decide based on the information available in the cache if it needs to go to the database to get the information or get the information from the cache itself. And basically what we were able to do is first of all we created a database utilizing Postgres. We then created a API DB context and our models, and we were able to implement this and connect to this database utilizing our entity framework migration, where basically we're able to create the table from there. And once we have done that, we created our caching service, and our caching service here we utilize the in-memory caching rather than a third party like Redis. And basically what we have done is creating this service, and we injected into our controller, and then we have added the logic where basically our application will be able to decide based on the information inside the cache if it needs to go to the database to put the information out, or if it actually can execute all of this from the cache itself rather than going to the database. So I hope this video was helpful. Please like, share and subscribe if you like this video. It will really help the channel as well. If you'd like to support me, please consider supporting me on Patreon. If you have any questions, please put them in the comments down below, and have a great day.